Thank you. Welcome. We're super excited to talk to you about how to bring your Android apps to the Assistant. I'm Adam Coimbra. I'm a product manager on the Google Assistant.
Hi, everyone. I'm Adam Koch. I work on the developer relations team at Google.
And I'm Sofia Altuna from our product partnerships team.
So App Actions is a simple way to connect the seamlessness of the Assistant to your Android app. Users can ask the Assistant to do something, and Assistant fast forwards into your app into the right place. So for example, instead of tapping through your phone when you just want to get out the door and start a run, you can just ask the Assistant, hey Google, start my run with Nike, and Assistant will automatically open Nike's app and start the run because Nike implemented App Actions. So last year, we presented an ambitious vision for App Actions, and we've been working hard to turn that vision into a reality. And so I'm really excited that App Actions is now available for apps in our first 4 categories: finance, fitness, food ordering, and ride sharing. Now, if your app falls into one of these categories, you can start building today and deploy your app to be part of our consumer launch later this year. But taking a step back, why extend your Android app to the Assistant? What's in it for you? Well, we know that there are challenges with re-engagement for mobile apps, and we think that part of that is because there's friction in the app experience today. Users have 40+ Android apps on their devices, and they need to remember all of them, navigate between them, navigate inside of them. It's a lot to keep track of. Meanwhile, Google is working hard to make Assistant the best way to get things done. And what's unique about the Assistant is that it allows users to just express what they want naturally, rather than worrying about what icon to click. And with the Assistant available on nearly 1 billion Android devices, this is a great opportunity to bring your app into this new entry point. You can leverage the Assistant to bring our more natural, frictionless experience to your own app and your own users. And this will become even more powerful with the next generation Assistant that we previewed yesterday in the keynote. It will unlock a much faster and deeper Android experience than ever, thanks to Google's advances with on-device AI. But we know that mobile apps will continue to be the foundation of how users get things done in Android. And so we envision a seamless connection with the mobile ecosystem to be a key feature of the next generation Assistant, and we're excited to work with you to make that happen via App Actions. To recap, App Actions in the Assistant will provide a much more natural way for your users to access your apps. Assistant's powerful NLU handles the user request and translates it into a deep link into your app, accelerating the user's journey. Here's another example. Let's say I just had lunch with Sofia and I need to pay her back. I can say, send $15 to Sofia on PayPal, and again, Assistant will fast forward into PayPal, but not only taking me to the right place in the app, but also passing the parameters from my request directly in, so like the amount and the name. And that allows the user to skip even more steps. Now, one of my favorite parts about App Actions is how simple it was for PayPal to build that. All they really needed to do was expose existing deep links in their app in a way that the Assistant could semantically understand. Now, this is enabled by connecting together 2 different technologies that happen to share the exact same name. The first is Assistant's built-in intents. So we are publishing a catalog of semantic intents that represent many, many different requests that a user might make. Now, as you can see on the left, we have the create money transfer Assistant intent. This allows Assistant to resolve that query, send $15 to Sofia. Now, you're probably already familiar with the second technology. That's Android intents, which are used by many apps for deep linking today. As you can see on the right, PayPal has already implemented their own deep linking scheme for sending money via Android intents. So to make this work, what PayPal really needed to do was add one file called actions.xml to their Android project that maps from the Assistant built-in intent to their existing Android intent. So as you can see, the core integration for App Actions is very simple and very easy to do. Again, App Actions is available right now for development. If your app is in one of our first 4 categories, again, finance, food ordering, ride sharing, and fitness, I really hope that tonight you'll come visit our developer documentation and start building. And we'd love to have all your apps as part of our consumer launch in the next couple months. And if your app isn't in one of those first 4 categories, stay tuned, because we'll be working on new categories and intents very soon. Thank you.
Great. So now you've learned a little bit about the background behind App Actions. I'm going to walk you through the technical implementation. I've broken the implementation down into 4 key steps. Supporting deep links in your Android app, telling the Assistant how to take advantage and use those deep links, optimizing your app further for the Google Assistant, and then testing and deploying your app actions to end users. Before I get started, I wanted to note a few additional things. First of all, implementation for app actions happens completely from within your Android code base. In addition, as much as possible, we try to take advantage of a lot of the existing APIs and infrastructure that Android already supports. And then lastly, App Actions runs anywhere where the Google Assistant runs on Android. That's from Android 5.0 Lollipop and above. OK, step number 1, Android deep links. For those of you who aren't Android developers, deep links are URLs that take users directly to specific content or actions within an app. The good news is, most Android developers have already implemented deep links in some shape or form in their Android application. So there may not be that much work for you to do here. However, we do recommend that you review our app actions documentation, understand the actions, and understand the parameters that we require for those actions, and make sure that your deep links can support them. Here's a few deep link URI examples. The first kind of deep links that we support are Android app links variety of deep links. You can see an example of an Android app links here. It just looks like a regular web URI. https mysite.com/example. Android app links requires that you verify ownership of your domain name and also your Android app. And that allows the Android system to connect through when one of those web links is encountered at the system level. Now, this is the recommended type if possible. However, we understand that not all Android apps can use these kinds of app links. For example, if a particular action doesn't have a web URL equivalent, or some content doesn't have a web URL equivalent, you can use something like custom scheme deep links instead, like you see at the bottom here. Now, I'm not going to go into too much depth on deep links because they're a very well-known Android technology, and they're documented on our Android developer site already. OK, moving along to step 2, telling the assistant how to use your application. This is where we're going to specify which app actions that we can support in the app, as well as defining something called fulfillment URLs and the parameters that we need. Optionally, you can specify something called Inline Inventory, and I'll get into details on that shortly. OK, so what are we going to do? Go to our Android project and create a new XML file in our resources XML directory. We've called it actions.xml. Then we're going to edit our Android manifest file, and we're going to add a metadata tag with the name com.google.android.actions, and we're going to link through to that XML file that we created. Let's have a look inside the actions.xml file. OK, there's a lot to take in here. So I'm going to spend some time walking through this because this is a really key part of the app actions implementation. First of all, at a high level, you'll see at the top we've defined an actions block. Within each actions block, we can have one or more action blocks, and this is where we map over to the app action that we want to support. Within each action block, we can define one or more fulfillment mechanisms. This is where we define the deep links that we can connect through to our Android application. And then finally, within each fulfillment block, we can define 0 or more parameter mapping blocks. And this is where we choose which parameters from those actions that we can support. Now let's look at the values that I've set in this particular example. First, I wanted to highlight intent name and intent parameter. Now, these values are pulled directly from our developer documentation. So if you're wondering where those values come from, you have to go and copy them directly from the developer docs. The intent name is the name of the app action you want to support. In this case, we've defined actions.intent.getExerciseObservation. GetExerciseObservation is a fitness app action where the user can ask the app for additional information on a particular exercise activity. For example, hey Google, ask Nike Run Club, how many miles have I run today? Moving down to the parameter mapping blocks, this is where we define which parameters we want to listen for in our Android app. You can see here that we've defined 2. One is exerciseobservation.aboutexercise.name. This is going to map over to the exercise that the user is asking about. For example, running or biking. The second one we've defined is exerciseobservation.measuredproperty.name. And this is going to map over to the exercise property that the user is asking about. For example, distance, pace, or calories. Moving along. Now I'm highlighting the URL template and URL parameter values. These values are completely up to you to define. The URL template is going to be the deep link through to your Android app. You can see here we've got an HTTPS style deep link, which means it's an app link style of deep link. You'll also note the curly braces in the URL template with some parameter names, and I'll walk through how that works in just a second. Then in the parameter mapping blocks, we've defined a URL template value for each parameter mapping. This is a name that you want to give to each of those parameters. In this case, we've given the simple names of exercise and property, and you'll see that those same parameters appear back in that URL template. Okay, but what is this URL template and how does it work? Well, the URL template value follows the RFC 6570 spec. Great, right? I wasn't familiar with that spec before working on this project either. But for most developers, all you really need to know is that those particular parameters are going to expand into the parameter name equals the parameter value when it's expanded from the template. Let's look at this example. So we've got our template at the top here, like we defined. Now the user may say something like, hey Google, ask my fitness app, how many miles have I run today? Now, as Adam C. was talking about, we're going to run our natural language understanding on this phrase. We're going to extract out the application that the user is asking about. We're also going to extract out the fact that they're talking about an intent that maps over to the get exercise observation action. We're then going to look at the text of that, and we're going to find out that they're talking about how many miles that they've run. And we're going to be able to extract out the structure parameters of running for the activity and distance for the exercise property. Then we can populate those parameters into the URL. You can see here what the final deep link URL will look like. https yoursite.com/stats with exercise set to running and property set to distance. I think it's pretty neat how we're able to do that. Now, some of you might have noticed there's some additional information in this user's request. The word today. This is going to be a time period that the user's talking about. But can we handle that as well? And the answer is yes, you can. Some actions support these kinds of parameters as well. And this one does. Now, I didn't show it in the actions.xml I was showing before, but if we had more space, we could expand and add an additional parameter mapping blocks to map to the start time and end time. We can then update our URL template, like you see here. And then now, when the user says the word today, it maps through to those parameters for us, expanding it into the actual values that we can use in our app. Here you can see at the bottom that start date and end date have now been set for us with the date of today, May 8th, 2019, at the start of the day and the end of the day. Okay, coming back to our actions.xml, there's one additional attribute I wanted to call out. That's the required equals true attribute that you can set on the parameter mapping block. This does exactly what you'd expect. It means that you absolutely require this particular parameter to be set by the user's phrase. If not, this fulfillment block will be skipped, and the next fulfillment block below it will be tried. Now, this has a couple of implications. It means that you must always have something called a fallback fulfillment. That's a fulfillment at the bottom of your action block that can pick up any action that the user says that doesn't match one of the previous fulfillment blocks. The other implication is that by default, required is going to be set to false. And that must mean that your app should be prepared to receive that parameter with no value set. Okay, so how does this all come together in your Android application? Well, the great thing here is now we're just going to use standard Android APIs to receive and understand those parameters. Here you can see some example code from an activity. We're going to read the intent that was used to start that activity. We're going to read the data URI that was used to start the activity. And we're going to extract those properties that we set in the parameter mapping block using getQueryParameter. You can see here we're extracting the exercise and property values. Now at this point, it's really up to your application as to what to do next. You could go and pre-populate a bunch of entry fields and then have a big button ready for the user to go and execute that action. Okay, coming back to a similar example to what Adam C. showed earlier in his section. At this stage of the implementation, Assistant is able to fulfill a request via deep link. The user asks the Assistant a query. We run our natural language understanding on the query. It identifies which app action to call, get exercise observation, for example. It extracts those structured parameters. It looks at the actions.xml from the application to find the right fulfillment block. It gets that URL template. It substitutes in the parameters. It calls through to the Android application, which opens up, and then the Android application processes those parameters and is able to execute that action for the user. Now, this is a good point to call out our sample that we've published on GitHub, the fit action sample. You can get it today on the Actions on Google GitHub repository. It's a really good example of how all of this flow that I just talked about works end to end. OK, one additional feature I want to talk about in step 2, inline inventory. This is where you can optionally tell the assistant about unique values in your app. Inline inventory is a lightweight way for you to customize the parameter values that your app expects to receive from the assistant. Now, this makes sense where you have a kind of finite list of possible values. A good example might be a restaurant's list of menu items, because they would be unique for each restaurant and finite in length. We've been working with Dunkin' in early access to test a lot of this out. So let's look at an example from them to illustrate how this works. The user may say something like, hey Google, order a blueberry crisp iced signature latte from Dunkin'. Now, the user may say that phrase, and we'll be able to extract the text from it. But of course, the user may say it in a slightly different way. They're not always going to get that exact product name. Inline inventory will let us tell the assistant about what values to expect and subsequently make it easier to handle within our Android application. Let's look at an example to illustrate. Back inside our actions.xml, we've defined something new called an entity set, and we've given it an ID of menu items. It's that ID that we're going to use to link back to the parameter mapping block that I was talking about earlier. Within our entity set, we can define a number of entities. I've shown 2 here as an example. Each entity has 3 attributes. There's an identifier, which is a unique ID that you give to that particular entity. There's a name, which is the canonical name for that entity. Here we've given it an Android string resource called blueberry latte. And then there's an optional alternate name attribute, which is an array of strings where you can define alternate names or synonyms for that particular entity. Here we've given it an Android resource, blueberry synonyms. Now, for the Android developers in the room, you'll know that the nice thing about using Android resources is that by default, out of the box, we'll get localization. So if these entities have different names or different synonyms for different countries or languages, you can define them in your Android resources as you normally would, and we'll pick them up for you. Let's have a look inside a strings.xml that would match with this. Here you can see we've defined the canonical names for these 2 entities, blueberry latte and caramel craze latte. And then we've defined a number of synonyms as well that would go with those, blueberry synonyms and caramel craze synonyms. OK, but what does this actually get us if we go and implement it? Well, now the user can say something like, hey Google, order a blueberry crisp iced signature latte from Dunkin'. Or they could say, hey Google, order a blueberry iced coffee from Dunkin'. And Assistant will be able to extract out those names, match it against our entities that we defined, and convert it over to the unique ID that we defined in our actions.xml. In this case, the ID was 12345A. We're then going to pass that unique ID over to your Android application instead of the name of the product. And you can quickly use that to show the user the right thing in your application and get the user to be able to complete that action quicker. You can see an example of this in action on the right here. All right, that was a lot of information for step 2. Going to move along to step 3, optimizing your app for the assistant. In this step, we ask that you implement 3 additional APIs. Why? This is really to help Assistant gain additional understanding of your application and of your app actions. I'm going to walk through each one, what it is, why it's needed, and go over the implementation quickly. OK, the first one is logging a result via Firebase. So what is this? Well, as Google Assistant loses visibility of what happens after the user is taken over to your Android application, we ask that you send us a simple success or failure signal so that we know if the user was successful in completing that app action. Why do we need this? It's so we can be confident in continuing to send users over to your Android application. Because without this, we wouldn't know if the user's having a good experience or not. The implementation requires that you first set up your Android application for Firebase. Then in your build.gradle file, go and add a dependency to the app indexing library. Now, I'm not going to talk about app indexing in depth in this talk, but for those of you who know it, you might be thinking, whoa, do I need to go and actually implement all of app indexing to implement this? And the answer is no. We're only going to use a very small part of the app indexing library, a set of APIs called the Firebase User Actions APIs. And the entire code for how you implement this is seen on this slide. Here we're in our activity, and we've defined a function called notify action success. This takes a single parameter of if that particular app action was successful or not. The first thing we're going to do is look at the intent that was used to start this activity and extract off a special token extra. You can see that highlighted here. This is a special token that we pass over from the assistant to your Android application in that deep link intent. Next, we're going to call upon a special assist action builder class from the Firebase app indexing library. We're going to set that token, and we're going to set the status, the success or failure status. Then we're going to call the Firebase User Actions API, and we're going to call a special method end and pass in that action. Now, you might be thinking, what is this end? Like, why am I calling end all of a sudden? Well, Firebase User Actions works like this. It has a start and it has an end. The start signifies the start of the action, but in this case, that happened over in the Google Assistant. End signifies the end of the action, and that's going to happen in your Android application. After that, we're going to call notify action success, the function that we created, along with status type completed if that app action completed successfully, or status type failed if it didn't. OK, next one, handling something called the search common intent. This is actually an existing Android API, and the developer documentation has been up on the docs for quite a while already. But what is this if you're not familiar with it? Well, it lets your app respond to a generic search query. For example, the user may say, hey, Google, search for sushi on my restaurant app. This would allow the My Restaurant app to open up and be passed the term sushi, after which it could run a particular search query within the app for that term. Why do we need this? Well, it's utilized by app actions basically as a fallback to provide a better user experience when things may not go according to plan. But we still have a high confidence that the user wants to use your application. Implementation is quite straightforward. First of all, go to your Android manifest and add a new intent filter to either an existing activity or create a new activity. Set the action to what you see here, com.google.android.gms.actions.search_action, and set category default like you normally would. Then in your activity, you're going to use standard APIs to read the intent that was used to start the activity and check the action matches the action we set in our manifest. We're going to read off a special string extra, search intents extra underscore query, which is going to be that search term that I was talking about before. And then at that point, kind of like before, it's really up to your app as to what to do next. If you have a search screen in your application, you're probably going to want to open that up, populate the text entry field, and execute the search for the user. The third API that I'm going to talk about, the Assist API. Now, this one has also actually been around for a little while. It's an existing Android API and is already documented on our developer website. What is this? Well, this provides the assistant additional information about what's currently being displayed by your application. And why do we need this? Well, it allows us to offer a better user experience when the users invoke the assistant or app actions while already using your application. Now, you might be thinking, well, when is the user using my application and calling upon the assistant? Well, hopefully you saw the cool demos of the next generation assistant, and you can see what the future holds for the assistant, where it can be everywhere and can help you no matter what kind of task you're trying to achieve. So you can see where an API like this could come in really handy for something like that. But even today, if you long press the home button on many Android devices, it'll call up the assistant as an overlay on top of whatever the user is currently doing. It's at that point that this API gets called to get additional information about what's currently on the screen. To implement this inside a particular activity, override a method called onProvideAssistContent. This takes a single parameter of type assistContent. And what we ask that you set is in the structured data field of this object, set a special JSON LD object based on schema.org markup. We have more details of exactly the values you should be setting on our developer website, but as an illustration, here you can see we're setting a schema.org type of menu item. And then we're setting the name parameter to Blueberry Crisp Iced Signature Latte, the item that would be showing on the screen at a particular time. Finally, if we use app actions, if we use Android app links for this particular screen, we're going to set the URL appropriately. All right, that's it for step 3. We're almost there. Stick with me. Step number 4, testing and deployment. So testing out app actions is particularly tricky because the assistant needs to be aware on our backend of the content of your actions.xml. To facilitate testing, we created a special App Actions test tool plugin for Android Studio. It goes and reads your local development actions.xml, it parses it and sends it up to our backend. And it creates a special App Actions preview just for the Google account that's logged into Android Studio. Then, on your test devices, as long as you're logged in with the same Google account, you can immediately test those app actions. Now, it's worth noting that that Google account must also have access to that package name in the Google Play console so that we know that you're an owner of that particular package. You see a screenshot of the test tool on the left. Now, it might be hard to make out, but what you can see is an App Actions preview has been published. You can configure a particular app action that you've defined in your actions.xml. You can set test values for the parameters that you've defined. Then it generates a special ADB command that can go and test that in the Google Assistant and call through to your Android app. You can click Run to run it on a device that's connected to your machine immediately. Or you can click Copy to copy the ADB command to use it in test scripts or a CI system, for example. And finally, deployment. As Adam C. mentioned earlier, you can start developing app actions today. And it'll go live for end users later this year. To get started, first make sure you've completed the form on our developer website so that we know that you're building app actions. When it comes to deployment time, you're going to upload your regular Android app binary, your APK or your Android app bundle, to Google Play Console as you normally would. We're then going to extract out that actions.xml and send it over to our Actions on Google backend to be processed. Now, it's worth noting that there is a manual review process that will take place on your app actions to ensure a great user experience. But this review process will not affect the regular Android app review timelines and deployment status in Google Play. OK, that was a lot of information. Let me quickly recap the implementation. Step number 1, supporting deep links in your Android app. Step number 2, telling the assistant how to take advantage of those deep links and use your app via the actions.xml file. Step number 3, optimizing your app further for the Google Assistant by implementing the 3 APIs I talked about. And then finally, testing using the Studio Test Tool plugin and deploying via the Play console.
Awesome. All right. So now that you've seen all of the steps for implementing app actions, you know how quick and simple it is. As a user, I also find it really refreshing. Now I can begin my app journeys with voice and fast forward a couple of steps into the right actions and content that I want to see. Here are a few examples from some of our early developers. As the Adams were showing us before, I can start tracking my run with no taps and no clicks, simply by saying, "Hey Google, start my run with Nike Run Club." I can as easily order food from some of my favorite apps, book a ride, or even check my financials, whether that's my account balance, my bills, my investments, or even send money to a friend using PayPal. Again, these are just a few examples from some of our early developers within the first 4 categories that we're going to be launching. And as we've mentioned, today you can also get started building actions like this from within your Android apps. Simply by creating a single .xml file, you can actually get started today. You can enable your users to discover, re-engage, and invoke your apps by voice across multiple touchpoints in Android. But that's not all. Because for simple answers, wouldn't it be nice to get those answers directly in the assistant? So I see some heads nodding. So great, we think so too. So in this next session, I'll talk about how you can bring some of your app content into the assistant. So let's go back to that initial example with Nike that Adam mentioned. Adam started his run by coming to the assistant and saying, "Hey Google, start my run with Nike Run Club." When he finished his run, he then came back to the assistant, and this time he asked for how many calories he has burned. Now you're going to see that this information is being displayed directly in the assistant via a slice. So let's pause this video and break it down into all the 4 steps. In the initial action, we're purely deep linking Adam into the Nike app to start tracking his run. However, when Adam then comes back to the assistant and asks for how many calories he's burned, Nike is displaying a piece or a slice of their app directly on the assistant via slices. Slices are part of App Actions. They're essentially the visual representation and enhancement of this feature. For queries that are one-shot, like this one, we recommend building slices so that you can display the answer inline on the assistant so that your users don't have to take any additional steps. Some people call slices the modern successor of Android app widgets that you may have already added to your home screen, and they're right. Slices are UI templates that can display rich, dynamic, and interactive content from your app directly on the assistant or even in Google Search. Through these templates, we're going to provide you with a flexible and rich mode of expressing your app that's also predictable and dependable. Slices can also be interactive. This template house many components to enable anything from rich content preview to inline one-shot answers. If you want to learn more about slices, please go to our website at g.co/slices or go on YouTube and see our last year's iOS talk on this topic. The best part about slices is that it's super easy to implement. You simply have to make 2 changes when creating your actions.xml file. First, you have to change the fulfillment mode to slice. And second, you have to update the URL template to slice provider instead. And then the URL template's parameters will expand into their values, as our second Adam mentioned before. But the one caveat is that App Actions and Slices only work on devices where Android apps are installed. But as you've seen, Assistant is in a lot of devices where apps are not installed. In this new age of assistants, people have smart speakers, smart refrigerators, smart vacuums, you name it. There's a lot of things you can talk to nowadays. And like this, we have many more new devices and platforms that are coming onto the market. Many of these are also not Android-based. And sometimes opening an Android app might not be the preferred way your user wants to engage with your content at every moment. So as users turn to many of these new devices, this is a new opportunity for you to reach them no matter where they are by creating conversational actions. Through conversational actions, you can create custom, multimodal experiences and extend your services to new form factors and new devices, combining conversation and rich UI interactions for the Google Assistant. Now, conversational actions shouldn't try to replicate your entire app on voice. Instead, you should focus on identifying those specific, unique toothbrush moments for your users that can be accessed across all Assistant-enabled devices. With 1 billion plus devices running on Google Assistant, you can build a strong presence at the moment where your users need you, no matter where they are. If you want to learn more about how to create conversational actions, please visit one of our many talks on these topics, including one here tomorrow at 2:30 p.m. called Designing Quality Conversations for the Google Assistant. And for those of you who are on live stream, you can also watch it live tomorrow. Let's do a quick recap. So App Actions, which include slices, and conversational actions are both part of the Actions in Google platform. When you look at App Actions, we just look at it as the first step in your journey with Actions. It can give you instant increase in reach and re-engagement for your apps across multiple devices on Android with relatively low developer effort. You can also then extend your brand even further by creating conversational actions and making sure that you're ready to engage with your users no matter where they are. So let's put this together by showing you an example. I'm a Citibank customer, so I have their Android app downloaded. So when I'm on my phone, I can check for my account balance, for my bills, and then I can always click on Open App to go into their app and take additional actions. Now, Citibank also created a conversational action. They've identified one of those unique toothbrush moments for their customers and created an action that lets you check for city-preferred tickets to events. So I'm Latin, if you couldn't tell. I live in New York City, and I love music. So I can use the Citibank action to check for Latin concerts in New York City. So no matter where I am, whether I'm driving, I'm at home, I'm on my phone, headphones, you get it. No matter where I am, as a Citibank customer, I can always reach them across multiple devices on Assistant. Lastly, let's see how all of this fits together from a high-level architectural perspective. So if I'm creating an app, and let's say for this purpose is my exercising health and fitness app, what I'm going to do first is put up a server that will be connected to my database where all of my users' information is stored. Then I'm going to create my app that will talk to that server to get the user's information and send it back to my app, which will render it based on the UI design of my app. The same concept works for iOS and for a web-based interface to your app. When you then go to create a conversational action, you're going to follow the same process. What you're going to do first is create a conversational action that will talk to your server using the same API and the same infrastructure that you've already provided. What happens then is for queries such as how many steps have I taken today, the assistant will take care of all the natural language understanding. It will understand what the query is and invoke your action. Your action will then also understand what the query is and fulfill that intent. In order to fulfill that intent, you'll use a webhook, which will connect to the server on the back end to provide the response back to the assistant. The key point here is that you, as a developer, don't need to rebuild anything new. You are using the exact same infrastructure, API, and identity mechanisms that you've already provided to your app to also provide a conversational response to your users through the Google Assistant. Essentially, you have one server, and you're just adding a new client, whether that's your Android app, iOS, website, or a conversational action. So with that, hope you're all as excited as we are. And no matter what app you have, you can get started today. If your app falls within one of the first 4 categories that we've mentioned, ride-sharing, health and fitness, finance, and food ordering, you can get started implementing and testing today by visiting our website that just went live yesterday at g.co/appactions. If your app doesn't fall within one of these 4 categories, do not worry. We have new categories coming up very soon. But you can also get started by optimizing for app actions today. You can start creating deep links for some of your key application moments, and you can also start experimenting with slices. All of our documentation is public, but if there's one link you need to remember, it's g.co/appactions. For those of you who are here with us today and this week, please come visit us at office hours and come check out some of our demos in the Assistant Sandbox. It's literally right around the corner. We still have a lot of I/O left, so we look forward to seeing you around. And thank you all so much for coming this morning.